Yes, hello everyone. Oh, it's looked like I'm starting a minute early. Wow. Okay, hopefully nobody's going to complain. Hi, my name is Bruce Momjian. I am a Postgres core team member, and I work for EDB. I've been with them for almost 20 years, which sounds like a huge amount of time, except when you realize I've been working with Postgres now for 30 years. So much for variety on my life. I'm excited to be giving this talk to you today. This is the first time I'm giving this talk, brand new for 2026. The idea for this talk actually came, as you can see from the slide, from Melanie Plagman. She approached me at the PGEU conference in Riga back in October, and she said, you know, it'd be really interesting if you gave a talk about what is missing in Postgres, what features doesn't it have. And I will tell you, as somebody who's written probably 60 talks over the past 20 years, that it's the idea for the talk is often the biggest challenge, right? Half the job is figuring out what topic to use. And then obviously the other half is writing it. I actually have two more talks that I'm working on. One is about the write-ahead log. I'll be probably giving that in Pasadena, California in March. And another one I'm working on, which is not finished yet, is on MCP, which is the model context protocol used for AI. And maybe I'll give that one, maybe in Warsaw, maybe in the fall in London. Anyway, for those of you just coming in, we're just doing an introduction about this talk. It's brand new. And hopefully we're going to get a lot of interaction from this audience, because I think this is an ideal topic to sort of just bounce around on, look at. The slides, if you're interested, are actually at that QR code and that URL right there. There are over 3,000 slides on that location and about 120, 140 videos. When you've done something as long as I do, they add up. A curious thing, actually, I'm going to share with people. My website has been up for about, 25 years. And as you can imagine, the technology's changed over time. CSS has changed, JavaScript has changed. What I actually found really interesting, just as a side note, if you have some old code and you want to modernize it, paste it into OpenAI and ask it to modernize it. I was shocked at how much insight it could give me into code that I've seen over and over again. But it gives sort of a fresh look at it and shows you, sometimes points out things that you didn't realize. So if you're ever trying to modernize some code like an old website, you might want to look at that. So again, I want to have a lot of discussion as we go, because I think it's going to be an interesting topic. Again, the topic here is what is missing in Postgres, and here is the outline. And what's really interesting about this outline is I learned something just writing this outline. Does anyone want to guess what I learned from writing this outline? Okay. What I learned from this outline is, aside from TDE, which is number 2, every other thing that people complain about that we're missing is related to performance. Now, having been with the project for 30 years, there was obviously a time when this list wouldn't have looked like this. It would say, hey, there's no point-in-time recovery, or there's no crash recovery, or there's no replication, or there's no partitioning, a whole bunch of sort of very foundational things. But as we've matured over these 30 years, we're now at a point where the majority of things that we don't have are really related to performance. And I think the sort of the theme we're going to see as we go forward here is trying to get a fresh look on whether these are foundational things that the database needs at 2026, or whether they're just things that were needed by other databases or needed 10 years ago, which maybe aren't as necessary today, and maybe that's why we don't have them. So we're going to try and see if there's a pattern as we go. I don't actually even know the answer to these questions, but this is the kind of thing that I wanted to look at. Any questions before we get started? Yes, sir. That's a great point. Some of the things that I list here are missing in core Postgres, but are available in extensions. And that's another theme we're going to see, that sometimes it's better off to have something that's available outside of Postgres that can be developed independently and added independently when necessary, instead of bringing it into core Postgres. Okay. Nobody complained I don't have a bow tie, so I'm going to call that a win. Just wasn't feeling it today. All right, so here's a list of Postgres releases since 2010. I am the person who writes the major release notes, so I kind of have a good feel for this. But the point I want to bring up here is that we might have missing features, but gee whiz, we got a lot of improvement going on every year. So as you can see, releases are typically about every 12 months. On average, we see 200 changes happening every year. Now, those are not all new features. They may be renames of variables. They may mean new options to variables. They could be a whole bunch of things. But it's pretty extraordinary that you have a database, a relational database that's putting out yearly releases with that kind of velocity. And of course, the reason that's happening is only because we're open source, because there's so much dynamism in what we're doing that that's just what happens. I like the number at the end there too. We're looking at about a 4% code change on average every year, which is surprisingly consistent, as you can see, over those 16, 15 years that we have data on it. Okay. Any questions about anything yet? Okay. All right. So let's start with the number one missing feature, and I'm going to point out the text here in blue. You see the blue URL there. I've written blogs about most of these missing features over time. So as we go through the slides, anything you see in blue there is effectively either a link to a presentation or a blog post, or a set of blog posts that I've done about this particular feature. You may not want to type it out, but if you download the slides and you click on the blue text, it'll take you to that URL very quickly. So that's what there. You don't need to write it down, just download the slides, click on the blue, you'll get there. So let's talk about TDE or what we call cluster file encryption, and then we can have some discussion about how people feel about it, because it's probably our most emotional missing feature, I think, at this point. As you may know, I spent a good 18 months working on TDE, primarily because I felt it was an important feature. Also, my employer, EDB, also thought it was very important, so they encouraged me to work on it. I was in a meeting once with a customer, and the customer suggested, this is kind of crazy, the customer suggested that the reason the community doesn't want to have TDE is because the vendors want to keep it as a proprietary add-on. I was like, no. I said, my employer encouraged me strongly to develop this feature and to give it to the community, and I failed in making a powerful enough case that we should add this code, and I'm going to explain why. But for all of these features, the idea that any of our employers, any of the employers of any of the community members would somehow interfere or hold back something, it doesn't happen. I've never heard of it happening. I've never talked to anyone who told me it happened. I'm not saying it never happens. I just said I've been around for a long time. I've never seen it. And in fact, it doesn't even work, because if one company held back their employees, another company would just make their employees do it. So we have a very dynamic project. And in fact, our community members are typically much more dedicated to the software and the community than they are in a lot of ways to their employers, particularly when we're talking about features and what's good for the community and stuff. There's almost like a barrier where the companies don't interfere. But let me explain exactly what this feature does, and then we can go over some of the details. So what we're seeing here in the blue is the basic storage of Postgres. So the basic running process of Postgres. So we have, in blue, we have the write-ahead log buffers on the right, we have the shared buffers on the left, we have a relation key, and we have a write-ahead log key, and all those exist in memory, okay? And in the file system, we have the base directory, which is where we keep all of our user data, and we have the write-ahead log directory, where we keep the write-ahead log. And what this cluster file encryption basically does is it decrypts the data as it comes off of the storage, and then it encrypts it as it goes back on the storage. So very straightforward. It's not doing anything at the process level, at the memory level. It's all happening at the storage level. Okay, and I have a presentation there at the bottom that kind of explains it. Okay, so what are the advantages of cluster file encryption? Okay, and I think these are pretty clear. PCI spec clearly now requires it. I don't know how many of you have been sort of up on the new PCI spec that came out in April, but they specifically disallowed storage encryption, which is what we've recommended as a community up until now, where we basically say don't use cluster file encryption, use encrypted storage. Like at the Linux level, you can basically say everything that goes to storage, everything that goes to the disk gets encrypted. And the new PCI spec clearly says that that is insufficient. You have to do some encryption at the file system level to distinguish it from the storage itself, okay? And that is kind of a new thing. I wasn't aware of it until somebody from Percona pointed it out at a conference. I think it was in Riga and a couple other times I've talked to them. So they're much more up on it. So there are customers who basically saying PCI doesn't allow storage encryption. We have to have something at the file system level. We can't use Postgres for these applications. Pretty serious problem. Another advantage, as people have complained about, is that if you do storage encryption, it requires coordination between the infrastructure team, which is the people who does the storage, and the application team who actually do, or the database team who do the database. So for organizations where the database team wants to encrypt everything, but they can't get the infrastructure team to install an encrypted file system, this cluster file encryption obviously handles that. And the third one is it automatically encrypts file system backup. So if you're doing a base backup, you don't have to run it through an encryption as you're backing up the file system. The data stored in the file system is already encrypted. So those are the advantages. Disadvantages are also pretty powerful. Questionable security value. So one of the things, again, I was talking to a customer in a European country, and they said, well, we really, if somebody breaks into the system and they can read the file system, we don't want them to be able to read any of the data. Okay, I'm like, okay, I get that. I said, well, what about if they can read the file system, can't they also read the memory? Like, because usually the access control to the file system, where you set the permissions on the file system, goes all the way down, and the access control on the memory is kind of the same thing. If you can see the file system, typically you also have access to the memory, and therefore you could just read the key out of the memory, right? Now you could say, well, that's hard to do, but Postgres is open source. We can't really obfuscate it. You can imagine if we ever did this, it would be trivial. There would be kits everywhere where you could just download and say, here's how you decrypt a key out of a server memory. And they would just do GDB and pull the symbol off, and bam, there's the key. There's really not a whole lot we can do about that. I suppose if we were closed source, we could try and play some games. But I don't know how effective that is, and we can't do it anyway. So when I did talk to the customer about that, and I said, how do you do that? How do you prevent that? And they said, well, we just have a policy that they're not allowed to read the memory. And I said, well, why don't you just have a policy that they can't read the file system too? Like, I said, I was hoping that you had like a magic wand. I actually used that term. I was hoping you had a magic wand which would somehow secure this. And a policy is really not like a magic wand in the same way that I was looking for. The second thing that I think held us back is the significant source code changes. So I go into this in pretty much more detail in the blog entry that you see listed right here, the most recent one, February 22nd of 2025. And effectively, to do this, the changes to the shared buffers are pretty small. I wrote the code, it's not that big. Changes to the write-ahead log, not that big. But to do it properly, you have to encrypt all of the temporary files. And because Postgres writes temporary files at a whole bunch of different places, now we got to have a key that is spanning all sorts of different places in the code. Some of the APIs are streaming, so you have to use a different cipher than you would for block storage. So I think we were making progress, but when somebody pointed out that, no, we have to do this, the temporary files too, and I was like, ow, that hurts, because that's a lot of changes. And because of the limitations I just talked about, they're like, okay, we're going to make a lot of changes here, but what's the value? We don't really know. I think regulatory, there's value, but the community is very immune to regulatory requirements. It's not, you know, like, oh, we're not going to get another sale. Oh, well, okay, we don't sell anything, so like, what's the big deal? Like, that's not good. That's not driving us, right? That drives Percona, that drives EDB, who also has a TD implementation. But that's to make a case for adding a feature, there has to be a technical argument. Regulatory argument doesn't carry very much weight as it would if it was tied to people's salaries and sales and stuff like that, but we don't have that. So again, we're much more immune. And then the third thing, which I think is probably, hopefully, a direction we can go in, is client-side encryption, which Peter Eisentraut has worked on a little bit, but he hasn't worked on it recently. I don't know why, but that is where the encryption happens at the client, and therefore everything gets encrypted, not only at the storage level, but even in memory, and the DBAs can't read the data. There's a whole bunch of advantages to client-side encryption, but again, it is a lot more work on the client. Percona is working on an open source TD extension. It is I think out of beta now, but it isn't fully featured. It doesn't do. I don't think it does temporary files. I don't even think it does WAL. So I think they're working on trying to develop, I think, a community around an extension, as you were saying. Whether they're going to be able to do that. Whether they're going to be able to do that cleanly with existing Postgres, I don't know. The way they're doing it now is it's open source, but it's an extension. But right now you have to use a specific source version of Postgres because Postgres doesn't expose enough of the API. There's some other issues around it about what level they did the encryption, which I think has to be improved. So again, whether that's going to get legs on it, I don't know. I did put the URL there to the Percona release. I think they're the only people doing an open source release. I know Cybertech has one, Crunchy had one, EDB, as I said, had one. Fujitsu has one. So one of the arguments was every vendor seems to have one. How could the community not do this? I don't know. It's very interesting. So any questions? Yes, sir. So the question is, what about the server logs? We've never even covered that. That's not even scope. I haven't even heard that one. It would be a logical thing to do, but we aren't even there yet. But that's a good point. Other questions? Wow. Oh yeah, Pavel. Yes. Yeah, the question is, what do you do with indexes when you're doing client-side encryption? He's absolutely right. There's a couple ways of doing it, but the problem effectively is if you create an index on one of these fields, then either it's useless if you add some randomization in there, or if it isn't useless, then you can identify duplicate values in different columns, and therefore that becomes another problem. So yeah, indexes, I do have a blog app about that talks about how to handle indexes, and I haven't heard really anybody give me a good answer of how to do that at the client side. You're absolutely right. Other questions? Okay, well, we can move on and come back to this. Great. Okay, so let's move into remember we have 3 parts. It's the TDE, which we covered. We're going to talk about the basic performance on a single host. That's section 3. And then section 4 is performance on multi-host architectures. So we've kind of left the TDE one, and now we're just going to look at performance for the rest. Okay. So this one is basically related to 64-bit transaction IDs. I don't know how many of you are aware, but Postgres effectively stores the transaction IDs in every row. There's actually 3 32-bit fields, although it shows 4 here. There's an xmin and xmax, and then a cmin and cmax, which are kind of combined in a way on the row. I'm not going to get into this, but there's some shenanigans about how we do this. But the bottom line is, because these transaction IDs are 32 bits, then we have to effectively every couple days or weeks or months or years do something called a freeze, which effectively takes the old transaction IDs, assigns them to a static value, and then effectively we can roll the transaction ID counter without there being a problem. This has been going on since I started with Postgres, or since the early 2000s. It's become more of a problem as systems get bigger. I have heard of users where they're doing vacuum or doing freezes every couple days because they just got so much volume. So this is an area where I think we're working. I think there is some work here that's trying to improve it. Somebody has a patch that I think the title is 64-bit transaction IDs for Postgres 15. And the email thread is still active. So 4 years later, they're still working on it. The only people I know who've done a lot of work on this is Postgres Professional out of Russia. They seem to have a special version of Postgres which does use 64-bit transaction IDs. And I think the way they get the real concern about this is that it would make the rows already 22. I'll show you here. It would increase the header size of each row by 33%. So we already have a fairly heavy row header, and now we're going to make it bigger. So the way Postgres Pro gets around this is they have like basically an epoch of the transaction sort of on a page. And if every row on that page has the same epoch, then they don't have to really do any freezing. And I think we're still kind of going back and forth on this about where to go. It would prevent freezing, but it does increase the header, and it does require significant source code changes. Any questions? Yes, sir. So the question is, if we were to do this, would it be backward compatible binary-wise, so we could still use PG upgrade? We're kind of struggling with that. I think the way I've seen, we're kind of taking it in pieces. So there's a whole bunch of sections in the source code that deal with transaction IDs, and we're basically chopping off some of the pieces to make them 64-bit aware as we get to actually doing this at the page level. I don't think we've really talked about where we would store the epoch on the page or whether it would be backward compatible yet. I haven't heard I think they came out gangbusters at Postgres 15, and now they're sort of backpedaling, and they're sort of doing it incrementally. I don't know what the final patch is going to look like, so I can't tell if this would be a breaking change or we could do it. I think they're trying to do it in a way that would not break the format of the page. Yeah, and we do that by putting, we're assuming, I think it's really optimized for large data loads where you're going to load a whole bunch of rows with all the same epoch of transaction ID, right? And if all the rows on the page have the same epoch, it's ideal we could just stick the epoch on the page, and therefore we could not have to freeze that page later on. I think that's the idea behind it. Other questions? Okay, next one. Optimizer hints. Man, I've been fighting this one forever. It has been just an epic battle for people who want it, don't want it. Why do you want it? I think I've tried to kind of summarize exactly what I think the state of play is on this. I think the major advantage, and I can't dispute this, is that it is very useful for quick fixes for optimizer mistakes. Okay, so if your query goes south and it's in the middle of the day and you just want to fix it and you don't want to research it and you don't want to, you just use the index, or just don't use the index, or just do a merge join, or just do a hash join. Right now, the only way you can do that, as I've said at the bottom, which the gentleman already mentioned, install PG hint plan, and therefore you have external control without modifying the application, I think, of being able to control the queries and change the plans. But there are a significant number of disadvantages, and this is where I'm going to get a little bit into why does Postgres need it just because everyone else needs it. Now, just anecdotally, I have talked to some people and read some things about the Oracle Optimizer. The Oracle Optimizer is this humongous file, which is almost impossible for one person to understand. It is full of so many special cases to fix so many humongous customer issues that anyone who goes in there is almost playing with fire, okay? Because the way that corporate typically develops software is they're really focused on the top 5% of their customers. I'm not saying they don't care about the rest of the customers, but they care about the rest of the customers in aggregate. They don't care about the individual customer who's at the 40th percentile or the 50th percent. They're cared about the top. And if a big customer at the top has problems, they will send an engineer in there to fix it, and they will guarantee that that fix will stay in their product forever, just to keep that humongous customer. That's the way corporate software development typically works. If I'm wrong, somebody can tell me. Postgres does not work that way. As you know, our optimizer is open, it's very modular, it's very easy to understand, very few special cases that I can even think of in there. I will say we've been we kind of stagnated, I would say, in the optimizer in probably the past 3 to 5 year span. I'm sorry. There wasn't a lot of improvement in the optimizer. Past 3 years, we had a lot of people, particularly from China, who have gotten involved in the optimizer, have brought really new ideas to the optimizer. Very hard to understand the optimizer, even for our experienced people. There's a small number of people in the community who can really understand it. But these people from China really spent the time, studied it. There's some people from HiGo. In fact, I have a link there, I think, from 2018, where I reference some stuff from HiGo. And they have some really good optimizer people. I was actually there. I was there in, I think it was November. I really. So my point is that most corporate developed optimizers are very fragile because they've got a whole bunch of special cases. Nobody can understand it. It's got a lot of fixes for big customers. Postgres doesn't really have that. There isn't a whole lot of surprising, gotcha, weird behaviors in there. So just because other corporate optimizers need hints does not mean that Postgres needs hints. I'm just saying that you don't necessarily need everything that everyone else has, because they may be there. The feature may be there to fix problems they have that we don't have. That's what I'm saying. Another disadvantage, typically to do hinting, you have to have some kind of locking of query plans. It prevents data distribution changes from having the optimizer improve the plan. So when you lock a plan, if the data distribution changes, that plan's locked. It's not gonna improve, and that can be a problem long term for customers. we often, when we get a report of somebody who has a bad plan, we start to dig into what assumption is incorrect. Is it that there isn't extended statistics, which is a common cause of bad plans and is easily fixed by creating extended statistics? And once you create extended statistics, which Thomas Vondra did probably 5-7 years ago, and that was the one last piece, I think, of the optimizer that I felt we really needed. Once we did that, the number of complaints about the optimizer went way down. Maybe the random page cost is wrong. Maybe the cache size is wrong. Effective cache size is wrong. There's going to be a whole bunch of things. And once we fix the core issue, we realized that the problem was not that query. It was a whole bunch of queries. So if we can fix the core issue, then a whole bunch of queries and a whole bunch of future queries are going to be fixed. Rather than focusing on our panic right now, which is the advantage I said, you need a quick fix, people run to the hints, but they're creating technical debt when they do that. And that's, I think, what I was going to probably point out. And again, the hints prevent diagnosing and reporting the problem to the project so we can fix it. So there is a little bit of self-serving here where we don't want it. We do have an extension that does it. But I think this is the state of play. I don't see us moving a lot here, particularly because there's an extension that gets people out of this problem. But I think ultimately the optimizer is getting better and better. The need for this is getting smaller and smaller. Even if there was a need 5-10 years ago, I don't think it's what it is today. Questions? Yeah. Yeah, so the gentleman basically saying that there's always going to be these performance cliffs where either it doesn't fit in memory and we can't identify it, and then performance gets really bad, and you're always going to need this ability to hint. Yeah, I think we're still, as a project, starting to understand what is potentially fixable and what is unfixable. and do we have unfixable? I would say before extended statistics, which Thomas Vondra did, I wasn't sure where that line was. Now that we have extended statistics, that line of what really can't be fixed is much smaller, and I don't even know where we are on that. And ultimately, I'd like to see us do more with feeding information from the executor back to the optimizer. That's actually on our to-do list, is the idea that when the executor identifies that we've hit a cliff, why is that information not sent back to the optimizer so future queries can know that there's this cliff there, right? It's a great. So that's maybe a little different than a hint, but again, it would fix a whole class of queries that I think would be really beneficial. So I think I still feel we have work to do here. Other questions? Yes. Yes, sir. Yeah. Yeah, that's actually, where was the one? Yeah, I have heard that from a number of people. I've heard that from Oracle people and SQL Server people. It gives you a crutch, but it doesn't make you go to the doctor to find the cause. And I'm really hesitant to be making decisions for developers, particularly if you look at the top one. Sometimes you don't have time for that research and you just want to fix it because you're down effectively. But how do you do that in a way that isn't sort of causing long-term problems for the system? That's really the question. Yeah, great point. Great point. Thank you. Other questions? Okay. Next one. Global indexes. All right, this is a beauty. As you know, we've been developing partitioning forever. I even have a partitioning talk there at the bottom, which kind of gives you, I don't know what this little, see this little B there? Just ignore that right there. I don't know what that is. That is me typing somewhere, and you always find one little problem, and that's my B problem right there. Um, so, so we've had partitioning for a while. I do have a partitioning talk again at that URL, which gives you the current state of our partitioning. Again, we do think incrementally, so it took us about 5 years, I would say, to get a fully capable partitioning architecture in place. But the one thing we don't have, and we have to decide if we do want it, is something called global indexes. We do have somebody working on it. It's not clear if it's going to go anywhere. I'm going to explain why. But let me explain what it does. So this is the typical way that that per partition indexes work, and that is that each partition has each partition has its own indexes. Okay, so there is not a central place to look for your indexes. So the indexes effectively are partitioned just like the tables, right? Just in one sentence. The indexes are partitioned the same way that the tables are partitioned. And that has some advantages because you probably partitioned because these tables are too big. So what do we have? We now have indexes that are not too big because we partition the indexes with the tables. The downside of that, of course, is that it's if you want to do a index check that is not partitioned by key, then you have to check every one of the indexes on every one of the tables. And that can be quite expensive, okay? What global indexes effectively promise is this. The idea that we can have a single index, just keep in mind, this is the So up top it says partition index. This is a partition index. So effectively what happens is that you have one index to go to for all the partitions together. But the problem is that this index typically is going to be huge, okay? And you're going to have locking issues. It's going to be very deep. So the reason you started partitions in the first place, and that is to limit data access and try and manage a table that's too big. You've now recreated the problem. Okay. So I know that there are relational vendors who have done this effectively, global indexes. And sometimes it works, like for very limited cases, but a lot of times it causes a lot of problems. And we've heard a lot of stories where people will create a global index and then 3 weeks later they'll get rid of it because it just caused too much problems. So again, the advantages are that you can do unique checks, you can do unique constraints that are independent of the partition key. That's good. You can do indexing of values that are not partition key. That's good. But again, you partition to split up very large tables, but now you got very large indexes. That's a disadvantage. Dropping partitions, which is something that particularly for time series, it's very easy to do in Postgres. Very low maintenance, very low overhead. Just drop them or move them or whatever. That's now going to be very expensive because now we got partition index values mixed in with that drop, and we got to do a whole bunch of stuff. And source code changes as well. So again, I don't know where to go on this. I'm just giving you an idea where we are. Questions? Yes? Yeah. So what he's saying is that he's had experiences where global indexes are meant to hide problems because they hadn't thought through the partitioning key, and then so that's probably pretty accurate. Yeah. Okay. Columnar storage. This is a cool one. I would argue we really don't have an answer here. I just don't think that the community really, if you need columnar storage, and I'm going to explain why you might want columnar storage, I just don't think we have a good answer at this point. What columnar storage allows you to do, instead of storing everything per row, which is the way we do there, they basically store it per column. So when you store everything per column, all of a sudden, if you have a lot of duplicates in a column, we can store those very compactly. For example, time series data, sensor data, a lot of duplicates. Typically store that in a relational system. You have one row. We talked about row overhead already. And now you're going to be storing this value over and over again. Okay? Being able to store them in columnar and then compress the columns works really well. Again, you only store the value once per table, and you can do compression very easily. But again, accessing a row, all the columns of a row is super expensive. Updates and deletes are expensive. And then we have to do major changes to the optimizer and storage. Citus does have an open source extension on this. I don't know how popular it is anymore. I've heard mixed reviews. It was popular for a while. I don't hear as much about it now. Maybe that's not as much of an issue right now. We do have somebody who's working on it, columnar storage for Postgres, as a table access method. So again, there is patches kind of going on here, but I haven't actually seen if that's going to make fruition or not. Questions? Okay. Next one, direct IO. I think I have a little better answer here. This is sort of an architecture diagram of Postgres. We have shared buffers on the left, write-ahead log buffers on the right, your f-syncing down. We already have direct IO for the f-sync part. The f-sync part, there's a direct IO flag you can put. But in terms of the shared buffers, there is no direct IO. Let me give you the gist of this. And then again, we have some URLs here at the bottom. Direct IO is great. It prevents double buffering by the kernel and the Postgres shared buffer cache, because right now, in a way, we're double buffering the stuff we have. It prevents copying of data from the kernel to the shared buffers. We can go right from the storage. Because of the way DMA works, you can write it from the storage directly into the process memory instead of having to go through the kernel cache. However, it could basically it could conflict with other I/O that's happening on the system. Again, if it's a dedicated system for Postgres, that's not an issue. But if there's other I/O going on, Postgres can conflict with that. A bigger issue, it's hard to explain, and I'm not going to be able to do it justice, is the idea that kernel memory kind of is this elastic memory that we can use for a whole bunch of different things like I/O caching and per process memory and kernel buffers and shared buffers. If we do direct I/O, then now we have to dedicate memory just for the direct I/O, and we can't be as flexible. So again, I don't know where to go on this. I do believe that our new async I/O is going to be using direct I/O more often. So I did talk to Andres Freud, and he said that long term, I know we just introduced async I/O with Postgres 18, but I think this is coming. There's more work for direct I/O coming. Okay, all right. Server-side threading. We're kind of toying with this one. Right now, the way we do it is we basically fork a process, and you can see from this diagram, the data segment for each Postgres backend is private. So there's a little bit that's shared, but the pink area is where we have all the shared information, but the process direct memory is effectively private. And that has a lot of advantages in terms of robustness, of crash safety, and so forth. If we go to a fork method, then now all the data is now shared. That's effectively the difference between fork and threading. Now you can see the data segment is the same across all the backends. But now we have a bunch of locking involved. We have a bunch of potentials for sessions to run out of memory and corrupt other parts of the system. So we're going very slowly at this, but we are kind of chewing away at it. Server-side threading does have some advantages. It can reduce switching time, and it can make sort of sharing of tasks a little easier. But it does make Postgres sessions less resilient, and the source code changes. So again, we're kind of dipping our feet in here. But I don't know where we're going. We're just looking at little parts now, and we're trying to make them thread safe, sort of in the idea that we may someday want to go down this direction. I don't think it's holding us back, but it might open there might be some things, particularly with async I/O, that we could do if we had one single threaded process that we can't do now. So, questions? No? Okay. This one I love. Internal connection pooler. Again, I have a URL on this slide, which explains where I think we are. Right now, the way we do it is if you want a connection pooler, it has to be external. Okay, it's PG Pool, PG Bouncer. Those are the two big ones. And effectively, it's a separate process. If we move the connection pooler into the Postgres process, we have some advantages and we have some disadvantages. So the advantages are that we can retrieve the connection once and pass the connection to the back end much more cleanly. There's less latency, obviously, in passing that happen. We can do more flexible authentication. People have been frustrated about how hard it is to do authentication, particularly something like a scram through a connection pooler. It just doesn't work because it was designed to prevent that kind of man-in-the-middle attack. And obviously simpler configuration. But if we do it inside, then we can't use it for failover now because when the server goes down, the connection pooler goes down at the same time and you're done. So I don't know if we're going to be doing it, but we have talked about it as an idea of something we want to do. And again, I have 2 blog entries about that. Yes. Yeah, what he's basically pointing out is there is a certain set of use cases where this would be useful. I don't think it would be replacement for external poolers, but there will be some cases where it would be useful, absolutely. Okay. Logical replication to DDL. This is something we're chewing away on. I believe there's some people from Fujitsu who have been working pretty hard on this. But as you know, we do replication great in Postgres. This is actually from my write-ahead log presentation, the one that I haven't released yet that I'm going to do in Pasadena in March. But effectively, we can once you connect the replica with the primary and you set up the table structure, it works. But there's no mechanism for changing of DDL on the primary to replicate to the standby. So again, what this would do is allow that kind of work. It would certainly simplify administration, but it requires a good number of source code changes. And particularly, it would require perhaps a change every time we do a major release because we're adding new features and those features would have to be now replicated. So it's a little harder to figure out how to do this. I think they're looking at like a JSON format. I know that Postgres distributed proprietary product, but it actually does this sort of replication of DDL. I don't know of anybody else who does. Oh, maybe PG Edge does. I don't know. But there's some companies who have worked on this replication, but community sort of stayed away because it's going to require regular maintenance, and we just haven't gotten to it. So that's where we are on that. Oracle like rack. This goes back to what I said way earlier. There's a sense that this is just too weird in architecture and too limited. Particularly, it scales CPU and memory, but it has reliability issues. It doesn't scale storage. There's a lot of communication problems between those, and the architecture is very complex. I don't find us ever doing this, but we do get requests for it. Again, it's probably an architecture that may have made sense years ago. It probably doesn't make sense today. We probably don't have a chance to really pursue this. Any questions? Right, what you're basically saying is we're not sure what the benefit is versus the complexity. When you look at those trade-offs, it's hard to see where to go. Yeah. Okay, let's take a look at the last part of this section. It's very, very short. Multi-master replication. A lot of requests for this. It's been around forever. But when you start to look at the pluses and minuses, you start to think, I don't know. So it is good for maintenance if you want to drain connections from one server and bring it offline. And it allows read-only scaling without any traffic management, which typically you'd have to put a PG pool in the front, which would route the reads to the replicas and the writes to the primary. That's usually the way we do multi-master. But it does require conflict management, and it isn't really a scaling solution because the writes have to happen on both servers. And the DDL management becomes very complicated. So again, I have a URL here that kind of explains where I think we are on this. We do have some people working on it, okay? Sharding, last one. This is basically the ability to split the data into different servers. We are working on this. I have some blogs about it. I think it's super useful, and I think we eventually have to go here at some point. So what I've done here in the last slide is I basically highlighted in green all the things I think we're working on and are being moved forward to some level, and all the things in red I just don't see progress on. I'm not saying it couldn't happen tomorrow, but as somebody reads the email all the time, I just don't see a lot of motion in that area, okay? So thank you very much. I'll bring that slide back up. Thanks very much. It's been a pleasure being with you. It's exciting to give this talk and be able to get your feedback. And again, I'll keep this slide updated as the community continues to fill in the gaps. So thank you.
Any questions?
So thank you for a great talk. It was interesting to see the trade-offs discussions. And I was wondering, like with your experience of so many years, like if you look back on some decisions that were made many years ago, probably similar trade-offs were discussed as well. And is there something like you would do differently from today's perspective?
So I think we've been incredibly lucky in some of the architectural decisions we've made. We've kept Postgres very small, and we've relied on the operating system as much as possible. That allowed us to move into the cloud very easily. We've kept our extendability. That's allowed us to move into JSON and AI very easily. I can't think of any architectural decisions we've made that have been really catastrophic. There's some we could have done better, but we kind of come back on it. We're like, okay, that was a mistake. And then there was a time we didn't think replication belonged in the server. We were doing everything with triggers. This is years ago. And we said, okay, that's wrong. So usually if we do something wrong, we hear about it really fast, and it's kind of hard to ignore. The fact I could get through a talk like this and nobody had a heart attack and said, what do you mean you're wrong, right? It shows that we're pretty open to the feedback we get, and we can't just do what we want. We have to listen to people. And if we ever stop doing that, then we're in big trouble.
Okay, last question. Nothing. Oh, thank you, Bruce. Amazing talk.
Thank you.